How to implement machine learning interpretability. In the rapidly evolving world of machine learning, ML, the ability to understand and trust the decisions made by models is becoming increasingly important. As ML systems are integrated into critical areas like healthcare, finance, and criminal justice, the need for interpretability, the degree to which a human can understand the cause of a decision, is paramount. However, achieving a balance between model complexity and interpretability can be challenging. This video aims to provide actionable steps to implement ML interpretability effectively. Point 1. Balance complexity. Choosing models with a balance between accuracy and interpretability is crucial. Complex models like deep neural networks, DNNs, may offer high accuracy but often at the expense of being black boxes. Simpler models, while more interpretable, might not always provide the best performance. Striking a balance is key to ensuring both reliable and understandable outcomes. Example 1. Decision trees. Decision trees are a classic example of interpretable models. They provide a clear, visual representation of decision paths, making it easy to follow how a decision is made. For instance, in a credit scoring application, a decision tree can show how various factors like income, credit history, and employment status contribute to the final score. While not as accurate as some more complex models, decision trees offer a transparent and easy-to-understand decision-making process. Example 2. Linear regression. Linear regression models are highly interpretable as they establish a straightforward relationship between input features and the predicted outcome. For example, in predicting housing prices, the coefficients in a linear regression model can directly indicate how factors like square footage, number of bedrooms, and location impact the price. Although they may not capture complex patterns, their simplicity and transparency make them invaluable for certain applications. Point 2. Use transparent models. Transparent models are essential for building trust and control in machine learning systems. These models allow stakeholders to gain clear insights into how decisions are made, facilitating better understanding and trust. Example 1. LIME, Local Interpretable Model Agnostic Explanations. LIME is a technique that can explain the predictions of any classifier in an interpretable and faithful manner, by approximating it locally with an interpretable model. For instance, in image classification, LIME can highlight parts of the image that most influence the model's decision, providing valuable insights into the model's behavior. Example 2. SHAP, Shapley Additive Explanations. SHAP values provide a unified measure of feature importance based on cooperative game theory. They offer a transparent way to explain individual predictions by showing the contribution of each feature to the final decision. For example, in a healthcare application, SHAP values can clarify how patient attributes like age, blood pressure, and cholesterol levels contribute to a diagnosis, enhancing trust in the model's decisions. Point 3. Document decision processes. Maintaining comprehensive records of model development and decision-making processes is vital for auditability and accountability. This documentation not only helps in tracking the evolution of models but also ensures that decisions can be reviewed and understood by different stakeholders. Example 1. Model documentation. Thorough documentation of the model development process, including data sources, feature selection, and hyperparameter tuning, is essential. For instance, in developing a fraud detection system, documenting each step ensures that any changes or updates can be traced back, facilitating audits and continuous improvement. Example 2. Decision logs. Keeping decision logs that record the outputs of models and the context in which decisions were made can be invaluable. For example, in automated loan approval systems, maintaining a log of each application's input features and the corresponding model output helps in reviewing and justifying past decisions, ensuring transparency and accountability. Conclusion. Implementing machine learning interpretability is not merely a technical challenge but a fundamental necessity for ethical and trustworthy AI. By balancing model complexity, using transparent algorithms, and meticulously documenting decision processes, we can build systems that are not only accurate but also understandable and accountable. These practices ensure that stakeholders can trust the technology, paving the way for broader acceptance and responsible deployment of machine learning in critical areas. Happy trading!